Hello everybody, and welcome to another video of programming for data analytics. Today, as you may have guessed from that clip, we are going to talk about functions. Now, I wanted to start with that clip because for some reason and whatnot, when I was a kid at school, they showed me that video about conjunctions and or and but, and it's a totally unrelated to programming, but for some reason that stuck with my. When I'm thinking about functions, I think of that video, and I'm cursed to always think about that. So I wanted to pass the curse to you now. So I'll leave a link on the description below, but it's kind of catchy, and yeah. So yes, I want to pass the curse to someone else now. So as I said, today the goal is going to be to talk about functions, and we have been using functions all along. It's just that, we haven't made our own functions. We've just been using other people's functions. But why let other people have all the fun when we can have some too and make our own functions? And so that's really what today is going to be about, is making your own functions. And so let's think back to math. Since the first time that I talked about functions in one of the first videos, I was, referring to them, and I use the mathematical, sort of version of a function, which is like f of x. Oh, hold on a second. There we go. So we have f of x is equal to 2x, right? That's a function, and what that function is doing is it's taking the value of the input, which is going to be x, and then it's doing something to that input. It is processing the input here. In this case, all it's doing is it's taking that input and multiplying it by 2. And when it finishes, what you get back from it, which is this is your result, that's what the function returns. That's your return value, okay? So in this case, if I feed this function the value of 5, it's going to give me back 10. Now in Python, if we created a function called f, and it did this exact operation, we would call that function like we were calling other functions so far, which is by putting the name of the function and then putting parentheses after it, and then putting any sort of argument or parameter that we are feeding into the function. So let's talk about that, what I'm talking about, what goes in between the parentheses. This is your input. This is what you feed to the function. Not all functions require input. Functions are just, you can think of functions as a block of code. And every time you call the function, it's going to run that block of code. Now, typically, when we use a function, it's because we want to have that block of code do something in relation to what we're doing right now. So a lot of the times you will see that functions require some form of input, whether it's a mathematical thing or it's something like print. Print is a function. So when we say, print hi, we are calling some piece of Python code that is actually going to make this happen, make this a reality of seeing hi being printed to the terminal. The argument that we're passing in, the input to the function, is actually what we want to print in the terminal. If we had nothing in there, then nothing would get printed, right? So it would be kind of useless. But there are some functions that don't necessarily require any input because, for example, let's just say that I'm writing code and I would like to put a bunch of little asterisks to separate some data that I'm printing out. And every time that I have to do the asterisk, I have to write a print function that has the right number of asterisks, and it's a pain. Plus, it might be something more complicated than just asterisk. So I could write a little function that you just hard code it to always do that in the function, and then I could call my function like AST for asterisk, and just call it without parameters because I've already created a function to do that specific task. And it's never going to do anything other than that. Now, of course, I could make the function flexible by passing in an asterisk in there and saying, okay, use this character as what you're going to print a bunch of, and that way then I can, if I decide I want to, instead of asterisks, I want to print hashtags or pound symbols, then I can do that, right? So inputs can only give you flexibility to your functions, but they're not necessarily required. When we learn about classes and structs and things like that in programming languages and in Python specifically, then you will see that we are also able to pull information that way for the data for the function to still have some sort of input, but not necessarily to the arguments. So we will see that later on in the course. But for now, if you would like your function to react to what you're doing, is you want to feed it some input. Similarly, when you're doing a function, and we are used to the mathematical equivalent of that, we have an input and we have an output. And that output is usually limited to just what the function returns, right? In in Python, you're not limited by that. You could make a function that not necessarily returns anything out. In fact, the way we have been using the print function so far, we don't have that return anything. Now you might be saying, well, it's printing stuff to the screen. Sure, but that's not a traditional return value like a math function would be, where like I am actually getting 10 out of this, So if I'm feeding F5, then this is giving me back 10, right? That's traditionally like a return value. With the print function, we're not really doing anything with that. I'm not actually sure if it returns something. It might for debugging purposes, but how we have been using print so far, there's nothing returned. And why is that? Because what the function is doing internally to actually print something to the screen is happening within the function, but we're not actually getting anything back from that function. There are other kinds of functions where you do get things back. So for example, I'm pretty sure this is a function, but even if it isn't, just imagine it is. Absolute value function. That returns the absolute value of a number. That's going to give me back 10. Or if I feed it 10, it's also going to give me 10. That's more of your traditional function. There are a bunch of math functions that you can use in Python that are going to act accordingly. You can also write your own functions that return things. You're not limited to returning an individual value. You can return multiple values, whether it's in the form of a list or Python's. This is sort of a Python specific thing. You can actually return multiple values with comma separated, and I'll show you that as well in a minute here. So why functions? The reason why we like functions is because of two major things: flexibility and not having to repeat ourselves. So when you're writing a function, you can think of that as this box that you've made. And this box is modular because you can feed it different inputs. And based on that, it might do some things in here, and it might also have some outputs, right? And so the power of this is that you can reuse this multiple times. So for example, you're doing a data analytics project and you would like to compute the average of a piece of a list. And you have multiple lists, but you want to compute the average of one of them for now. You could write some code to compute the average. It's not, you could do it in a single line actually, but imagine that instead of average, you're doing something more complicated, variance or something, whatever. So, or covariance. At least that'll be a little bit longer. But the point is that if it's something that you're going to be reusing, then it might be wise to turn it into a function, because otherwise, if you're writing code, let's just imagine that this is some code, and then in here we have the code to compute the average. And let's say it's this much code. Okay? And then you have more code, and then you need to compute the average again. So you either rewrite the code or you just copy and paste it. And as you're writing more code, you might find yourself having to use the average thing again. So you have to copy and paste it. Now suppose you want to modify how you're computing the average for optimization purposes or whatever it may be. You're going to have to go back in here and modify all of the instances of that. So like now you add a slight modification there on these lines. You got to add the modification 3 times. So that kind of limits you and becomes hard to keep track of those changes. Furthermore, copying and pasting is not ideal. It's making the code unnecessarily long. Instead, what I'm going to do is I'm going to take this code and make it into a function. And I'm going to call that function like AVG. And if there's some input, I will have it here. And if there's some output, I will return that. And now I can just do my ABG and call it with whatever I want to pass the average to. And I can do that in all three instances where I was doing it before. And here's the major benefit. Number one, your code becomes a lot smaller. Number two, if you need to modify your function or the way you compute the average, well, there we go. So yeah, sorry, little bug. If you want to compute, if you want to modify your function or modify the way you compute the average, you can do that very easily by modifying the code here. And that is going to automatically propagate so that when you call the function, it's going to use the latest version. So you have that added flexibility, and your code base becomes a lot smaller. And it's also more intuitive, because if you pick a good function name and you have a good comment explaining what it does in addition to the function name, then it's readable. It has this idea of abstraction where you don't need to know how the magic happens behind this average computation. You just know that it does what it does. And that's all there's to it. And you don't need to mess with it. So some other people can use it. You can share this code and some other people can use it. And that's the beauty of functions. So far, I haven't even told you how print function works. I told you that it prints to the screen when you call it, but we've never talked about why it works or what kind of dark magic has to happen in the computer to actually make it function correctly. Because you don't have to. Because that's the cool thing about functions is you use them and you forget about them. Use the next one. And so that's very powerful. Coding is supposed to make our lives easier, not harder. Functions are a major step towards that direction. Okay? So hopefully I've motivated you to have an interest in functions. So now what I want to do is I actually want to start doing some functions. So first, let's switch over and look at what we have so far. So we have a little print function. We've been using it all along. We know that if we run this, it's going to print out this is a function because that's what we have in here. Dark magic is happening here, but the point is that it works. All right. Other functions that you could use. Let's try out this absolute value one. I think it's -10, and let's print that out. There we go. We get 10 out of that. Whether we pass -10 or if we pass 10, of course, we also get 10, right? Here's something interesting about this. This is like function inception. We have a function inside another function. If you notice here, ABS is a function itself, and then the result of that, because it's a valid returning function, that result is then being kept and passed to the print function so that it can be printed to the screen. Now I could have done this by storing it in the variable first. So I could have said x gets the absolute value of that, and then I can call print on x, and that would of course work the same way. But if I want to save some space, then I can just do it in a single line, right? And so that's another cool thing about functions is you can nest them together to save space and not make unnecessary variables and other whatnot. As you can see, this is the same as thing, and I could change these things all day long, massively, just for fun. Let's just do that. It's totally unnecessary to do this, but we're going to take the absolute value of the absolute value of the absolute value. Of course, once you take the absolute value of something, then the absolute value of that is going to be the same thing always. So they're kind of unnecessary, but it's just, to show an example. As you can see, that does indeed give us 10. Of course, this is a little bit excessive. It reminds me of Scheme, which is a programming language that has function galore. The only sort of, I would say, slight issue with this, which is actually the thing about Scheme that it reminds me of, is we have this ridiculous amount of parentheses here. Each of these parentheses is closing one of the functions. So that one closes this one, and then the next one closes this one, and so on. And if you have the wrong amount, this thing will not compile because the parentheses won't match, and it's going to give you an error. Unexpected end of file while parsing. So, that's the only issue. If you got a bunch of nested functions, you got to make sure you match your parentheses, just like if you're doing a list and then the list inside another list and so on. And, I would discourage someone from doing this level of functions within functions, but it's possible, right? So, that shows you that you can have a function within another function, no problem. In fact, there's a concept in programming known as recursion that we really won't cover much in this class. In fact, I don't know if I'll even cover it at all. But it is something that all computer science students have to learn and be good with, because recursion is a way of writing an algorithm where a function will call itself. It's an alternative to doing iterative code, looping, and you basically solve a problem by calling yourself in a smaller subset. So, for example, if I want to print a list out, I would say, okay, here's my function, print out one element, and then call the same function, but feed it the same list minus one. And you basically rinse and repeat. And that's all I'll say for now. But if you ever hear that word, that's what they're talking about. In data structures and fancy things, recursion can be useful to actually develop an algorithm to, again, the hard part of coding is to take an idea and convert it into code, right? Recursion is just another tool to do that. But it's a tool that people particularly find hard, so there's no reason to talk about it for now. But yeah, anyways, so these are your basics for functions, of at least using them. But what if you want to make your own function? So let's go ahead and create our own function. And it's going to be pretty easy. All you got to do to create your function is write the word define, spelled just DEF, and then give the function a name. So I'm just going to call this my first function. The identifier rules, in case it's been a while, so I'll refresh them for you, is the same one as any variable or anything you're naming in Python. It is going to be a alpha character, so A through Z, uppercase or lowercase is fine, but it is case sensitive. And then you can have numbers, but it cannot be the first character of that name. So, this is valid to have numbers afterward. It's even valid to have numbers right here. What's not valid is to start with a number. And then the other character you can use is, I believe, an underscore, okay? But I would avoid using an underscore just in general, because that's more of a systems thing and you might run into naming issues. So anyways, after you write the define and you write the function name that you want, all you have to do now is put your parentheses and put a colon like you would with an if statement or a for loop or any kind of loop in general, okay? That is a function for the most part. Well, there is one more thing missing from that, and that is what the function contains, all right? So like, think about an if statement. When you write an if statement, you say like if 1 is greater than 2, the code will not run right now because you have to have something in here. Whether that's something like the word pass just to make it do nothing, or actually have code that does something useful, right? So technically speaking, you have to have a body to your if statements and your for loops. And similarly with a function, it has to have a body. So for now, I'm just going to do the same thing I did for the if statement. You just put pass. It does nothing. So this is a function. It does absolutely nothing because it has the pass in there, but it's good enough for now. Okay? So again, when you're writing a function, you're going to write the word def, define. You're going to write the function name. You're going to put parentheses, and then you're going to put your code. Okay? And that's basically the syntax for a function. Now, these parentheses here are very similar to the parentheses you see when you call a function. That's no surprise there. And actually, the parentheses are going to list any arguments that the function requires. So the print function has some kind of argument in here to be able to actually process that. But before we put in some arguments, let's just test out whether this function works, okay? So, how do you call a function that you've created? To call a function that you've created, you're going to call it like any other function that is in Python. You're going to put the name of the function. So in this case, it's my first function. And then you're going to put your parentheses, just like you would with any other function. And that's it. In this case, this function has no arguments in it. So unlike these two, so that's good enough. This right here is what is considered a function call. And this here is your function definition and declaration. Okay? There's one caveat about writing functions and using them. Whenever you write a function, you have to actually define the function. So you have to write this code here above, physically above, wherever you call the function. So if I try to call my function here, I would get an error. And the reason for that is because you have to teach Python what your function is and what it does. And when Python is running code, it goes from top to bottom. So it's like running code, 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 code. And then if it sees the function call here, it's like, huh, what is this function? I've never heard of it. And it gives you an error. In fact, it says something like undefined function. However, if I have my code like this, where I'm code, 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 code function, it's like, oh, look, it's a new function. It's called my first function, and it does whatever. Python remembers that. It adds it to a list. It's just like, okay, this is a function that they've made. At least for this runtime. When the program terminates, it forgets. But at least for now, it knows that this function exists. So then when it sees this function call, it's like, huh, this is not a function I'm familiar with, but let me check my list. And it's like, oh, okay, it's in my list. See, he declared it earlier. Okay, so let me just go ahead and run that function. Okay, so again, in summary, whenever you make a function, you have to declare it above where you use the function. Otherwise, you're going to run into that error. So let's go ahead and watch this function in action, which is going to be absolutely nothing because it's not doing anything, right? So not very exciting. But the code did run, which means it worked. Unlike if we had this before, like I said, this would cause issues, even if they're next to each other. Technically, this line runs first, so you are going to get an issue saying that the function is not defined because, yes, Python is not seen it yet. Python's like, imagine you're reading a piece of paper and you're putting your hands beneath the line you're reading at. So, like, if you're putting your hand, you know, and you're blocking every single line, so like, I'll give you an example. So Python goes like this. It's like, okay, there's this line. I'm going to run that line. Okay, I'm going to run this line. Next, I'm going to run this line, this line, this line, this line, and then this line. It's like, huh, what is this my first function? I've never seen that before. Error. Whereas if we don't have this, Python's running it again like this, and every time you run it, it forgets. It's like, you know, amnesia. Then it sees, okay, you're defining a function. What does this function do? Okay, it does pass. Cool. Then it sees this, and it's like, oh, I remember this being a function. You know, let's say it writes it here. There's a function called my first function. So now, when it sees this line, it's like, oh, I have that function already because he declared it. So now I can go and actually run that code. So Python just works like that. But anyways, let's make our function a little more exciting. So let's do some function inception and actually call the print function and say, we are a function. Let's run the code again, but this time, let's write something else here. So maybe we call it a function that says before function. And then we have some code afterwards that calls another function that says after function. Makes it easy to see. And let's run this with the debugger on. Okay, so as we run this, we hit the breakpoint, and then we see it says print x. So if we keep going, we can see that we have the nasty absolute value thing, and now we're declaring the function. So as the function gets declared, it gets stored somewhere here in memory that we have such a function that exists. And you can see here under the variables, there's a function variable. It says my first function. So it's been stored there somewhere in the behind the scenes. So now it sees this function print. Of course, it knows what to do, which means print before function. Notice what's going to happen here. It sees the function call, and the code automatically jumps to the beginning of the code for the function. That is because, you know, again, this is a little computer science-y and tech stuff, but the code itself is loaded into memory. And when you see a function, it has sort of the location of that code for the function so that it loads that part of the code into the immediate next thing to run. So it's kind of changing the location of the little pointer that says what line to run. So if we pull again our little pseudo piece of paper, what happens when it sees this line is it looks for the beginning of the function and then it goes from there. And it's going to run through the entire function, and when it finishes, it's going to go back to the context before it. That's known as context switching, I believe. Okay? So it runs that, says we're in a function, and immediately jumps back down here and continues running that code, which is the after the function, and then it terminates. Okay, let's add in some more code in here. I'm just gonna put some math. So I'm saying x is equal to 2 plus 3, and then x plus equal 1. I don't know, x is equal to 2x, and so on. Then we have our print thing, and then maybe we have some more code, like x plus 2 gets stored in x, and then we are going to print out what the contents of x are. So now our function looks a little bit more exciting. So now what I'm going to do is I'm going to use a function that actually gets used more than once, because that's the whole point. You're doing it as a function, right? Because you want to use it. You know, if you're writing code, it's good to split things into functions, but if you're not using the function more than once, I do question why make it a function in the first place, because you're only using it once, so you're not really saving anything. But some people will argue that you should still make it into functions because it makes the main code more readable without having to see the nitty-gritty or behind the scenes. So readability is an argument for using functions, even if you only use them once. But I would say for this class, for data analytics and for getting things quick and dirty done, just throw everything together. And if you're only using it once, don't bother making it into a function. You can do that in the optimization stage later in your process. Don't try to optimize things so early in the process, and then you find you don't even need this code, so you wasted time making it into a function. But if you are finding yourself using something repeatedly, then convert that into a function to avoid repeating code. Okay? So let's run this code again and watch it in action. All right, so now we are seeing the function declaration. As you can see, it just jumps immediately to the bottom because internally what it did is it saved that. And now we are going to see the first function call. As you can see, it goes to the top of the function. It starts to run that code. We can see the value of x right there. We can see it getting to 6, 12. We can see that we are in a function. Now we got the number 14, and it's going to print 14 back. And now we're done with the function, so now I can print out after the function. Then we got another before function print. Then we can see the function again. You can see it's running it all over again. It's going to print out we're in a function. It's going to print out 14, go back, print after the function, and then be done. So as you can see, you know, it's no longer just following code up and down. I mean, with loops, you saw how things kind of spun around. It's kind of like that here, where the code can repeat itself. You can, of course, write more functions of your own and put them inside other functions that you made. So let's make a function that takes a number and multiplies it by 2, since we did that earlier. So we're going to call that f, and we are going to take, in this case, a number that we pass in, and we're going to multiply it times 2. So let's talk about how to pass in data to a function, okay? So those are called arguments, and arguments are going to be specified in your function name inside of the parentheses, and you can add as many as you want, but you have to separate them by commas. So in the math world, we typically see a function with just one argument, like this, but it is also possible to pass in multiple arguments, and they do typically separate them by commas as well. So no surprise that programming takes that inspiration from there. So if I would like to pass a function here, you're going to have to use a variable. And that variable, it doesn't really matter what that variable is, because all you're doing is saying the first argument that is passing into this function, I'm going to store it in this variable called x so that I can reference it inside of the body of the function. If I have multiple variables, then I can separate them with commas, but I definitely want to use a different name for each variable. So now the first variable, the second variable, and the third variable are going to be referred to as x, y, and z. So then in the function itself, I can process the information that is coming in from those variables. But in this case, we're only going to have, we're starting out easy, so just one variable. And we are going to just take that and we're going to multiply times 2. Okay? After we multiply times 2, I'm just going to go ahead and print it out. In fact, let's just store the result in another variable called y, and then just print that out. That way we don't change technically the variable that we passed in. Okay. So now, if I want to use this function, I have to call it. So let's go ahead and call it right here after this, maybe. So I'm going to say f, and then I'm going to call print here so that we can see the results of this, just so that we can see what the answer is. But I do have to pass it with an argument. If I don't pass it without an argument, I'm going to get an error. So let's actually run it like this to see the error. You're not going to get the error immediately. It has to hit that line of code. So there we go. So it says missing one required positional argument x. So this error is actually very descriptive about what's happening. First of all, you have the line number. It says line 22 where the error is at. Yes, it is. And it says that the function f is missing one argument. Positional argument means that there's different positions. So argument 1, 2, and 3, first, second, and third argument. Those are the position of the arguments. So it's saying that it's missing one of those arguments. And it's required because, as you saw, the function requires a parameter or an argument. And that argument has the identifier of x within the function. So it's also helping you out to see like what argument this is talking about. So yeah, I mean, it's useful to read these errors because they're pretty descriptive. And so how do we fix it? Well, two ways. One of them is if we actually intended to call this with an argument, then we have to redesign our project to handle that. So we have to make a function that doesn't take an argument. Or in our case, we do want it to take an argument, so what we have to fix is the function call itself. So let's go ahead and pass a 5 in there. So now, if we run this, then we will see that it works. But before I do that, I am going to go ahead and make that function call here, and I'm going to actually pass in x in there. Okay, so I'm going to have two function calls because I want you to see how things start to get all crazy and jumping around all over the code. So let's run it and let's see how it goes this time. Okay, so we can see the prints, we can see our define being our define f of x function being done, my first function being done, and finally we get some code to run. So we get before function. So here we have the f5. So you're going to see that immediately jumps into the f5 code. We can see here that the x parameter is a local parameter that has 5 in it that is passed in because we passed in f of 5. It's going to get multiplied times 2 and the answer stored in y, as you can see here. And then it's going to print that out, as you can see by the 10. So this is still not a valid returning function. This is just doing computations and then just throwing them away at the end after doing whatever it needs to do. But that's okay. That's as far as we've gotten. And as you can see, it finishes and goes back here to this code. Next, it's going to run my first function. So as you can see, it's running that. We can see the value of x is 6, and now it's going to be 12. And now it's going to hit our f of x function. So now it's going to jump to that code. And it has to remember that it came from here because like the first time we went to this f function, we came from this piece of code. But this time we came from this piece of code. So when that happens, Python remembers where you came from, the previous context. It keeps that information stored in what is known as a stack. So it'll know where to go back and what the next line of code is. Otherwise, it'll get confused and like run this code instead of running this code. Okay? So now we have our parameter 12. So before we had called it with 5, but in this case, we're actually calling it with 12 because that's what this x contained. Now, I want you to notice that the x here is not necessarily the same x as here, right? Because this x is just whatever the parameter is. So the parameter that was passed in here as an argument was 5, and here it happened to be 12. So just because this x and this x share the same name, and it's because of what's being passed in, doesn't mean that they always have to be the same. This variable name is just living in that function, and it does not affect anywhere outside of it. Okay? So moving on from there, we can see that 12 becomes 24, and it's going to print out 24, and then it's going to go back to here, because this is the function call that called it, not this one. And then it's going to keep running the code there, and then it's going to go back here. It's going to run code, call this function again, run that function, call our f of x function again, run that f of x function, go back to my first function, run that code, go back to this, run that, and be finished. So as you can see, it's no longer as simple as just kind of going top to bottom, right? Things can go all over the place depending on where these functions are. So it's very important for you to make sure that you understand the logic and the control flow of the program to make sure that you don't, cause any errors. When it comes to functions, you definitely have to obviously declare them above. Like in this case, f of x has to be declared above my first function because my first function is referencing that. Otherwise, you'd have issues. Now, let me give you an example of something that is really bad to do. So here I have the f of x function calling my first function. This is what's known as a circular sort of recursion, because you have a function that calls another function that then calls you back. This will not work because here, let's just show you. Let's just show you what happens. So we see what functions pass in there, but when f5 gets called, f5 runs, and my first function runs. My first function is running, and then it calls f of x, which then runs f of x. And then it runs my first function, and it runs f of x, and it's just going forever in circles. You see that? It's never going to terminate. As you can see, it's just printing that. And if I remove the breakpoint and I just let it run nonstop, it's going to basically crash. And I guess it didn't give me a crash error here, but it's basically going to do a stack overflow because it's going to run out of memory, creating all these. Because every time that it calls a function, it needs to remember where it came from. So it's a tiny bit of space. You do these for a lot because, I mean, it's going to go nonstop forever. Eventually, you're going to run out of space of remembering what the previous context was, and the program will terminate. Didn't really give me the error here, but if I were to run this in terminal, then I should see that happen. So here, let me run that for you really fast. So we get the error here. Recursion error. Maximum recursion depth exceeded while calling a Python object. Notice the word depth in there. Depth is because every time you call one function from another one, you're going deeper and deeper, like an Inception. We have to go deeper, right? And so eventually you go deep enough that you run out of space. And there are some limits here that you can probably expand. So you're not really running out of your entire memory, but you're running out of whatever was dedicated for this recursion. So either way, it's bad. So you don't want to do that. You know, bad things happen. So don't try this at home, kids, kind of thing. Okay? So be very careful when you're calling a function from another function that you don't end up in a circle. In programs like C++, this wouldn't even compile because, like, when it sees this function, it would have to actually see the code for it. So it would have to see this code. So this wouldn't compile. But in Python, it's like, yeah, I'll take it. But at runtime, it's going to get stuck. So don't do that. You can call functions from other functions, but make sure you don't create a cycle. Or at least that there's a way the cycle terminates. So, base cases, if you know what recursion is. So again, now you've learned how to do a basic function, and you've learned how to pass a parameter in. Let's talk about return. Okay? So if we're trying to make our equivalent math representation of this function, we want this f of x function to actually not just print out the result, but actually return the result as part of the, as part of what it does. Just kind of like the absolute value function will do, not how the print function works. And so it turns out that it's actually really, really easy to do that. All you have to do to return a value in Python, so instead of printing it, we're going to return it this time, is just write the word return and then write what you want to return. So in this case, the answer to my computation is actually in the y variable, so I would put y. I could have also written this as a single line of code and said return 2 times x, because that's going to do the multiplication and then return result. But of course, if you're learning, that's okay to do it this way first, then to jump in and do it this way, okay? Because it's a little bit more intuitive. That's it. That's all you got to do. And now your function is no longer just a function that computes something and prints it out and throws it away. here it's actually going to return the result. Of course, if I just leave it like this and run it, it's not very exciting because we're throwing away the result here. As you can see, we're not really storing it anywhere, but we are storing it in this one because we are printing it. So let's go ahead and take a look and see that in action. So as we run it, we see the print F5. It's going to take the 5, it's going to multiply it times 2, and it's going to return that. So as you'll see, when it returns it here, we haven't seen it yet, but when I run that line, bam, we see that it prints out the 10. So we can see that it worked out. So now if I want to store this value into X, so let's say I want to update X with that number, then it'll be more interesting to see it on that case. Okay, so that's running f of x, printing out the 10. Now we're running my first function. The value of x is 6. It's 12, but now we're going to call f of x. So it's going to run f of x. It's going to do 2 times x. So it's going to make 24. And it's going to return that, which means 24 is going to be written into x. So you can see here that the VS Code is really nice about this because it says return f24. So it's telling me what the function has just returned. So we're going to see this number replace this number as the assignment happens. Bam. You see that? And it remembers, by the way, that this is what it returned, which is pretty neat. So as you run the rest of the code, we can see that now the number printed is 26. We can also hear that the return f from before is still kept in there. So that's pretty neat. Good for debugging purposes. So, yep, there's me running the second one, and there you go. So that's easy. So functions are easy. Like don't overthink them. They're really there to help you out, not to make your life harder. So yes. Let's try something else here. Instead of storing this in the value of y, let's store it in the value of x, and let's try and just return x, but more importantly here, let's throw away the value. And let's just see if this x is going to change this x. Okay, in fact, let's get rid of the return, because I want to show you something interesting here, okay? You have to watch very carefully. So, okay, let's do this. We're going to run my first function. As you can see, the value of x is containing right now 12. We're going to call the function. So 12 is being passed in. So now what we're doing is we're taking 12 and multiplying it times 2, right? So as you can see there, that the 12 times 2 should be 24, right? Here, actually, here, let me just so you can see it, let me write a print statement. Because it kind of jumped it really fast there, so I want to take it a little slower here. Okay. All right. Here we go. So we got 12 in x, and we're going to call the function f of x with 12 as the argument there for x. We can see that the 12 here is going to be multiplied times 2. Now we can see 24 there. In fact, if we print out what the content of x is, it says that inside of f we have a 24. Okay. Now we are back to f. And I want you to notice that x contains still 12. You see that? So even though x inside of this function was 24, as we could see here, after the function ended and we have our x still contains 12, and it's still going to be printing out here 14 as it was doing before. So the point I'm trying to make here is that this parameter that we are passing in, this x value, is not the same as this x value. So even if I try to modify the argument here that I'm passing in, it's not modifying the original. And that's because in Python, it's making a copy of it per se. And it's a local copy that you can then modify, but it will not modify the original one. So in some programming languages like C++, you can explicitly either pass by reference or value. And what that means is that when you pass a argument in a function, so if you have a function foo, and you pass in the value x, and you're calling this function from somewhere else, if you pass by reference, what's going to happen is if you modify that argument inside of the function code, it would actually change the contents of this x. So you know, if this is my function, this is C++ now, but if that's my code, and somewhere in the code, I'm actually calling, so x has 5, and let's just say here, x gets 3, okay? So if I call foo with x, and afterwards I want to print out what x contains, in a language like C++, if I'm actually passing this by reference, then this would actually modify the original x, which means that x would change here. If I'm passing by value like I'm doing in Python, then even though the x is being changed here, it's only the local instance of x is being changed. This will remain the same and untouched. And that's really important, because if what you're trying to do when you're doing a function is to modify your passed-in argument, it's not going to work. You know, so if you have functions whose job is to double the number and then pass it back, such as this is kind of doing, then it's not going to work, because it is passing them as a copy. Okay? So that's kind of an important point to make sure that you understand that. If you would like to modify these values, then your best bet is to either pass something other than data, so you can pass like a list or something, or you could just return it using the return statement and then assign it, just like we were doing before by saying x equals that, and then now add that back in. And so now we're actually going to modify the x here because of the return statement. But this itself is not modifying it, even though we're doing it here. Okay? So very, very important. Another thing I would like to clarify is that I am saying the word argument and parameter interchangeably, but the traditional way of defining those is that an argument is actually the value that is sent to a function when it is called. So when I'm calling this function here, this value that is contained here, so this 12 or whatever, that's an argument that I'm passing to the function. A parameter, on the other hand, on a traditional mean, is this up here. When you're defining a function and you're listing the variables inside of your parentheses in your function definition, those are your parameters, function parameters, okay? So function arguments are when you're doing the function call, function parameters are when you're doing the function definition. Okay, so let's just write that out. So arguments are going to be in your function call, and parameters are going to be in your function definition. Okay, that's like the purest way, but I'm guilty of mix matching and calling each and or depending on the mood. But traditionally, that's what argument and parameter are representing. Okay, so if you use either one, I'll understand you, but just be aware that that's the clean and proper way of speaking. Okay. Let's just go ahead and do a couple of other examples. So, by the way, my recommendation coming from other languages to Python is that I don't like throwing functions in the middle of actual code. So here we have code that's actually running, and then we have functions, and then we have more code that's running. It's kind of messy and hard to keep track of. My recommendation to you is to put all of your function code at the top of the Python script, and then write code that's actually running. In fact, at some point maybe we'll get to talk about how main works in Python so that it mimics other languages like C++. And so that's the more traditional way. So you'll see that usually use that approach. Just put all your functions first and then put your actual code afterwards. Don't mix and match, because it makes it harder to read. And also, if in the future you wanted to refer to a function here that you coded here, then you can't, right? You got to move physically the code above it so it works. So by putting functions at the top always, you save that from being a problem. Of course, once you learn about being able to use multiple files, which is pretty easy in Python when we talk about imports and whatnot, then you'll see that it's a good idea to put all your functions in a separate file than actual code that you're running. Okay, but for now, I'll let it be as it is now, because it's just an example. So let us write another function. I'm just gonna do it down here and imagine this is like a brand new file kind of thing. So I'm gonna call system clear, which will clear it out. I don't want to delete the code because I want to leave it there as an example for you. But if I run this right now, it should be empty. Right? Yeah, okay. So let's make a function that takes 2 arguments. So we're gonna call this, add function. It's gonna take 2 arguments, which we're gonna call A and B. Again, you can name them whatever you want. These are just identifier names. And the function is going to take the numbers A and B and add them together and return the result. Surprise, surprise, it's called add. So now I can add, 2 and 3. I can add 2.5 and then 2.1. I can even try, and none of this will work in Python. It should. I can try to do this. Okay, and I guess I should probably call print around these just so that we can see some of the output. Otherwise, it's not that exciting. Notice that I'm putting spaces. You don't have to. You can just do it like this. Sometimes I like to do that because it's a little more visually appealing. I already spoiled what the answers are there because I forgot to put a breakpoint, but let's do it again anyways. So as you can see, when we call add, it runs the code. It takes A and B and adds them together and return the result, which is 5. So you can see that you are indeed getting a 5 from that. Here you're getting whatever that is equal to, which is 4.6. And finally, this is interesting. When you do hello in the world, remember that the plus is not addition in that case. It's concatenation. So it's going to concatenate the result into one new string and return that, as you can see by that. So kind of cool. So this brings up an important point, actually. And I was just doing this actually for my C++ class the other day. In C++, we have a thing called templates, which allow you to basically pass any type of argument to a function. Doesn't matter the type, which Python just lets you do by default, as you can see here. Like, I am not defining whether A and B are numbers, strings, lists, whatever. I don't have to. Python just handles it, which is amazing, and I love it. But in C++, you can't really. You have to use a template if you want to do something like that. And even then, like, it's not that easy. But you do run into the same situation that you run in C++, and that is that you have to consider when you're writing a function what the type of argument that is going to be passed in is going to be. This function is called add, and I did it with the intention of using it to add numbers together, whether those numbers are integers, floating point values, or whatever. No problem. That's what I intended to do. Perhaps I didn't intend people to use this with a string. And if they do use it with a string, it happens to work, as you can see here. It will actually work, but it does a concatenation, which is like maybe not what I planned. So you have to be aware of that. When you're running a function, you either have to write code to check whether this is okay or not before you run it, or you just have to put that in documentation like, okay, this function is meant to be called with numbers. Don't call it with something else because bad things can happen, right? So just be aware of that when you're passing in parameters, those parameters can be anything. And in some cases, it can cause issues. In fact, let's try to pass this with a tiny list. Let's make 2 lists. We'll call those X and Y. And then let's call the function with X and Y as the parameter. So now we're calling it with 2 lists. Okay, so first we got those 3, we got our 2 lists, and now when we run it, we add it together, and what are we going to get out of that? We're going to get a list that concatenated both lists. That's pretty cool. It makes sense because lists allow you to do that, but now let's take one of these lists, and then as a second argument, let's try to say add 2, just a number 2, and let's see what happens in that case. Bam, we have achieved an error. So in this case, we are getting an issue because we are trying to concatenate or put together a list and a single number. And in this case, Python allows you to concatenate lists together, which is, again, one of those like amazing things. So that means it just takes the two lists and basically squishes them together, append them, puts one after the other and makes a new list that contains both, as we saw with the 2, 3, and 23, which is cool. What it does not let you do is if you try to do like a list and then append that to or concatenate that with a number, you might intuitively think like, oh, well, that should just like append that to the end of the list. And that's a fair assumption, but that is not the way that Python works. In the case of Python, you have to actually use the word append if that's what you want to do. Because if you're using the plus symbol, it will try to do a concatenation, which it cannot do between a list and a number, like an integer. So that's what the error is saying. You can only concatenate list to a list. So you can only go list and list. And it's even said in parentheses, not an integer, because that's what you're trying to do. You're trying to concatenate an integer and a list. So it's like, can only concatenate a list, not an integer, man, to a list, right? So it's like passive aggressive telling you like, you can't do that. So that's kind of funny. So yeah, as you can see, we get a nasty error and the thing terminates. So you have to take that into consideration. Now, we haven't talked about exception handling and how to handle this, but if you want to limit what arguments and give out your own errors and things like that, don't forget you can always use the is instance of. So you can say like is instance, right? And then write like the parameter and then the type. So you can say something like if A is an instance of a list and and is instance of B is a int, then you can return an error saying you can't do this, and then just not return that result. Instead, just return like a 0 or something, just so you don't give an error. So you could do something like that. And so now, when it checks this, it's actually going to go into this if statement, and it's going to return 0 and not give you a crash. It's just going to print a 0. However, maybe you were expecting it to concatenate, and so that's bad, right? Or maybe instead of returning 0, I have an idea. Why don't we actually just append it? So take A, and then append B, and then return A, which is the new list that has been appended. That's actually, I like that more better than an error, because errors are cool, but they stop you from doing things. So better to work around the problem, right? So there you go. So now, as long as we know that's what we're expecting to do, if we were not expecting this, then that's bad. If we were expecting to add like the number 2 to each of the entries of the list, then you have to write code that does that, right? But in this case, we are saying that if they decide to do this, add with a list and an int, we know that we can't do this. So instead, let's just append it. So again, you can handle these weird situations, but you have to be aware they exist. So, sometimes you can do that. Sometimes you can just write in your documentation and say like, please do not call this on an integer. If they do, they're going to get an error. So that's one way to handle it. The other way is to just, work with the problem and do the best you can. So either is fine. I just want to make you aware that when you're doing a function and you have parameters that are being passed in, that those parameters can be anything. So be aware of that. And the same applies for the return statement. The return statement here varies from things like an integer to an entire list, right? And so if this is something that you're going to take the result of the add function and maybe add it to another number, you have to be aware that the number what you're getting back from add could be a number or a list. And if it's a list, then you could cause other issues later on if you expected a number back, right? So that's another thing in your design that you have to take into account, that unless you are very specific about what the type is that you're returning here, then it might change depending on what code you're being passed in. In addition to that, do I want to talk about... not really. I'm going to leave a reference to W3 Schools, I think, that has a good reference on functions for things like arbitrary arguments and keyboard arguments and a couple of other cool things. Default parameters, maybe. I'll show you default parameters. That one is good enough to show. Because there's a lot of things you can do with functions, and you can get really, really fancy with functions, and we just don't really need to go that in depth for just this class. I will show you one more example though with the default parameters. So for example, suppose that let's just suppose that like the add function, suppose that the add function you wanted to you want to take two numbers, usually the two numbers you want to add. But suppose that like if for some reason, again, this is a big random thing, if they only pass in one number, your add function is just going to take that number and add 2 to it. Okay? In that case, you want to use what's known as a default parameter. And the way you do that is you just add an equal sign to the parameter that you want to make default, and then just go ahead and throw in what the default value should be, like that. There, done. This will cause some issues because of the way this is set up, though. I feel like it might cause issues. I don't know. Oh no, it's happy about that. Okay, not bad. But now let me show you what that's going to do. So if I call print and then I say add and I pass in like a 6 there, before it would have given me an error and said like you're missing an argument. Now it'll actually just fill in with the default value, which is 2, and then just run it with that and give me a result of 8. So if I remove this default parameter thing that I added in, so if I go back and leave it as it was and rerun the code, you will see that it gives me the error again, missing one argument, which is B. So same error we saw before. So default parameters are useful when you want to give flexibility to your functions. I don't expect you will run into that situation. It's more of when you're writing functions for other people to use, and because when you're using them, like, okay, I'm always going to expect a parameter. In fact, you may want to give an error if you don't get a second parameter, because like I would argue that this add function doesn't make much sense to just pass in one number. It's like, huh? So, default parameters can be nice for flexibility, but don't feel compelled to have them. At the end of the day, if the input isn't valid, you just want to give an error out. You don't want to try to like, if somebody gives you a car and says go and sail on that to like Europe, you can do as much patching as you want, but like you're probably gonna sink in the ocean, right? So you want to be like, no, I need a boat. So yeah, basically, little bit of metaphor for saying it's okay to give out errors sometimes. It's good because you want to know that's a problem, rather than just trying to like, do wonders just to get something, like the customer's always right kind of thing. So yeah, don't be, as you saw here, we passed in some lists, so you can pass lists as arguments. That's perfectly fine. You can return lists as arguments. That's perfectly fine as well. If you just want to write a prototype function, like you're writing your code, as I said, you're gonna have a function that's gonna be called, multiply, but you still haven't had a time to like actually write the function out. But you want to kind of leave it as a placeholder. You have to put something in here. So again, you can use the word path, right? Just like with an if statement or with a for loop, you want to put the word path so that the code compiles, right? So they're just placeholders, and they're perfectly fine to use. So just be aware that you can use them. Again, recursion is a whole nother adventure that we're not really getting into, but it is a cool way, an alternative way to run iterative code. Pretty much all iterative code can be run recursively, but it's not ideal because recursion takes a lot of overhead because of those call stack things that we saw that had an error. So I would avoid it as much as possible unless you are good at it and there's just no other way. But typically with big data, you do want to avoid it. And there are some features in Python to take recursive code and actually not do the recursion. but I'm not gonna talk about them at all. I believe it's called pneumatic code. I forgot the name, but I might leave a reference at some point in the description. Final example for functions that I mean, we'll talk more about functions when we get to classes, but let me show you very fast how to return multiple things from a function, and that'll be the last thing, because this video is getting a bit long. We're past the hour mark, so. All right, so let's just write a function that we're going to call it split num. Okay, and this function is going to take two parameters. And the purpose of the function, always when you write a function, I highly encourage you to write a couple of things. This is actually important. Documentation. You want to write what the function expects, what the function returns, and what it does. Okay? Always put documentation like this over each function you write, especially if they're complicated functions, then you should have a lot of documentation. That will tell you how to use the function, because like what it takes, what it gets you back, and what it does to that, right? And so that, you know, that will be basically, if I've never seen your function before and all I know is how to call it, so this function call, I should be able to read this and understand how to use it. I should not have to read the code. I don't want to read the code. That's too much work and effort, right? You want to be able to use functions without having to understand how they work. And so that's kind of important for documentation, okay? So just a good habit to get into. Okay, so our split num, you know, what's going to be the input? It's going to be two numbers. Or actually, no, let's just take one number. It's going to take one number. And what it does is it's going to divide the number by 2 and return, well, I was trying to do like a factoring, but factoring will take a little bit of effort. So maybe, okay, we're going to divide the number by 2 and by 3 and return both results. Okay? So some sort of weird form of ghetto factoring. Okay? And so the result is basically two numbers that are a division of 2 and 3. Now, right now, these two lines kind of look similar, but again, it's because it's a very simple function. But if it was a complicated function, you know, big explanation goes here. This is just a summary of what the output is, or the types as well. Okay? So anyways, let's just write a function that does that. So let's just make some temporary variables. We're going to call it x and y. And the x is going to take a divided by 2. We're going to do integer division. Oh yeah, I could do that. How about that? Let's make a function that does the division and returns what? The division result and the remainder. That's a much better example. Okay? So parameter 1 is division result, is integer division result. Parameter 2 is remainder of that division. Okay? And what it does is divides the number and returns the result and its remainder. Okay? I like that much better. And we'll change the name to my divide. Sounds very deep, like the name of a book, like an autobiography or something. That'd be kind of cool. Okay? So x will take the normal division, and then for the remainder, we can do oh, what are we going to divide by, though? Well, let's just say we're going to divide by 5, okay? Let's just hard code that in. Or maybe make that be the second parameter. One number, so dividend and divider or whatever. So number, I'll just call it numerator and denominator. In my head, that makes sense. Okay, and we probably would want to update the description, but for now, I want to get to the example. I think you get the point of the documentation. Okay, so there's my division, and then for the remainder, I can use the modulus operator, like it is here, and that's it. I'm actually done. So now, how do I return this? If I want to return more than one thing, there's a couple of things I can do. One of them is, of course, I could just make a list and return that. That could work as long as I'm aware that it's returning a list, but then I would have to update my output to explain that. Or I can return two values. So I can actually say return x and y. And that's actually going to return two things from a function. Now this is kind of trippy. I guess not that trippy, because in math, you know, this would be the equivalent of saying something like, I suppose that could work, maybe. Or in this case, it's more like A, B, or whatever. So I guess in theory, that's not as weird. Some math functions, I guess, can do that. So yeah, return x and y. And so now, if I would like to call my function, let's go ahead and call it with 10 and 2. So that one's going to give me no remainder, but then let's do something more interesting, like a 108 divided by 5 or 7. You know, when in doubt, use primes, right? So, okay. And then here, let's just do one more. Let's pick primes. Is 51 a prime? No, it's not prime. Yes, it is a prime. Let's just do 41. Okay. All right. So let's put a breakpoint here so we can go there. Okay. So when we run this code, well, okay, let's just run it, but nothing's going to happen. Not very exciting, but yeah, it's going to run it. It's going to return those two values, and then nothing's going to happen, right? So to be more, how do we capture the values? Okay, to capture the values, if you just, here, let's just start by trying to do print and seeing what happens with print. Let's just do that with one of them and just kind of see what happens, okay? So if I do this, you know, it's doing the divisions. So we can see here that x and y contain the 5 and the 0 because it's just a division by 2 and there's no remainder. And when we call print on this, we see a tuple. Remember tuples? And there they are. That's kind of cool, but you know, maybe we don't want it to be a tuple. Maybe we want it to actually get the values individually, right? So how can we do that? Well, let's try that with the second one. Just make new variables. We're going to call those I and k, or d and r, or remainder or something. And then you comma separate them. You don't need this space. You can put them together if you want. Put the assignment operator, and then put your function call. And then, and now you can actually print them out. So you can put like, there's your D, and then print out, there's your R, so for remainder, and do that. So that's another way you can do that. Let's do it again here. And here we just print them out like that, okay? So if we run this again, we can see that this runs, we get the x and y. We can see there that prints the tuple out. But for the second one, when it runs, we can see that D and R have our values, as we can see here, 15 and 3, which I assume is the result of the division. And then you can print them out individually. So you can process them further and so on. So that's really nice. And that's something that Python can do, but not other languages. And here we get another example with 41 and 7, which you get 3 and 6. Okay? So 3 times 7, 21. That looks weird. Oh, wait, no, we're doing 41 divided by 7. That's why. Yeah, okay. That makes sense. So, yeah. I guess. That feels weird. Something feels off about that. Oh, no. It's because I'm looking at this number. These are numbers, 5 and 6. Yeah, so 5 times 7, 35, and then 6 to 41. Okay, that makes sense. Okay, I was getting thrown off because I was looking at like the 3 and the 6, but no. This is the result of that, so I was tripping. That's why this is nicer, because it's labeled. Okay, so yeah. Not as commonly used, I will say, to try to do this, because it's kind of weird and finicky, but it will work, and it's definitely something you can do. If you would like to have a function that returns multiple things, you can do that. My personal preference, if you want to return a assortment of values from a function, and you still want to keep it as one single function, is to use a list and returning as a list, such as what this would be, this method here. And then of course, you know what order things are in a list so you can process them. But this will return to you a tuple and you can handle it that way. Or you can also assign it like this. And I have done this before as well. So it's not like it's blasphemy or something to do this, okay? So ultimately today we have given you a very, very, very brief, but I would say somewhat thorough introduction as to how functions not only work in Python, but how you make your own functions, which is the primary goal of today. So, you should start to split your code into functions, because remember, when you're working in code and you're struggling and things like that, the approach you want to take to solve a complicated problem is to divide it into smaller problems that are easier to solve and tackle. And those could be your functions. So each of your functions are things that you can solve. And then when you make a function, you can do function calls to test the function. And that's actually known as unit testing. And it's a very popular thing. So then you can just really test the function to make sure that piece of code works 100%. You have like 20 different function calls for this average function because you want to test all the edge cases. Once you're confident that that piece of code works and that function is like fully operational, fully functional, then you can move on to solving the next step of your problem. And when you're done, you will have these set of functions that solve your entire problem. So all it takes now is to call them in the right order, or put them together, or have a call within the call or whatever, like we did with the absolute value, and then have your problem solved. And it's a much better approach than sitting down and trying to solve your problem from scratch. Like, okay, I'm just gonna write the code right now to solve the entire problem in one go. Maybe you can do that, but I can't, and the majority of people cannot do that because it's just too much work. If something goes wrong, then you have to figure out where that issue is, right? You have a bug, and debugging a large chunk of code is a pain and not a nice thing. It's a lot easier to debug tiny pieces of code and make sure they're robust than to try to debug a massive program. People will go and write 1,000 lines of code before they even test a program once. Of course, it won't work when they test it, and now you got to look at 1,000 lines of code and see where your problem is. Not the way. Write 50 lines of code or write 10 lines of code into a function, test the function, make sure that works, move on to the next one. Make 20 of those. Once you tested all 20 and you know they all work, if you run the code and something's wrong, then you know it's not in any of those functions. It's in whatever you did to put them together. And it's a lot easier to figure that problem out that way than it is to try to just solve everything together. So I highly, highly, highly encourage you to take that mentality of being modular when you're code. Okay? That's how you are going to grow as a programmer, and ultimately, the better you become at Python, the more encouraged you will be to actually use it in your projects. If you suffer every time you're coding, then you're not going to want to code, and that's totally natural. So, you want to make this easy for yourself so that you can actually make this a tool that you want to use, not one that you are like using just because you have to. Okay? So again, I thank you for your time. I hope to see all your functions functioning and doing everything cool. So until then, I'll see you next time. Take care.